So I apologize. It looks like we've reached our maximum time. Screencast-O-Matic is telling me I'm too wordy. I got to speed it up. Anyway, so where we left off is what we just said is that x equals 5 would have been a 0. You could also think of that 5 as a solution to this equation. Another way to solve this equation here is if you factored, being a difference of squares, you would be able to say x equals 5 is a solution from this portion right here. X equals 5 is a solution. Well, x minus 5 was the factor that got that solution. So these two statements right here, while not equal, very closely related, essentially one step different. And again, if you were to graph this function, 5, 0, and actually negative 5, 0 would be the two x-intercepts. So if you found x-intercepts in the past, if you found solutions in the past, if you found factors in the past, you've been finding zeros along with it. You might have just never called them a 0 before. So that similarity is going to be important as we talk more and more about zeros in the future. For example, right here, find the zeros of this function. Well, if you factored before, then you found zeros before. You just never called them that. To find the zeros, you literally take your f of x and you replace it with 0. That's why it's called zeros. Here, if you set up this equation, then this looks like something you probably factored in Algebra 2. You look for a common factor, you say, all right, x is in common, leaves me with a trinomial, and that trinomial also factorable, so we would say x is a factor. Looks like x minus 2 is a factor, and x plus 1 also a factor. Those are all factors, which means we have 3 factors. We've got 3 zeros. Using the zero product property, we're going to create 3 equations. And again, so right here we've got one solution. If I add 2 to both sides, I get the second solution. And here, if I subtract 1, I get x equals negative 1, I get a third solution. So you have 3 zeros, 0, 2, and negative 1 are the zeros of this. 0, 2, and negative 1 are the solutions to this, if you want to think of it that way. And if you wanted to refer to it as factors, well, these would be your 3 factors right here. 0, x minus 2, and x plus 1. All right. Why is it important to find zeros? Because it's going to help us graph. When we find a 0, we are going to be able to graph that as an x-intercept. What's nice about zeros is they tell us a little bit more about the graph. For example, if you are solving a problem and a 0 appears twice, meaning you get the solution in 2 different places, all right? An even amount of times, I jumped around a little bit. If you find a 0 an even amount of times, that means the graph is only going to touch the x-axis. It's not going to pass through it. So, it might just touch and then pass through. Where if a graph had an odd amount of zeros, that graph, let's say right here, is going to pass through the graph. Whereas over here, it only touched the graph. And that's dependent upon if the 0 appears an odd amount of times or an even amount of times. Again, it's one of those pieces of information that helps you connect everything together and a good way to check your work to see if your graphs are correct. All right, let's do another one. Find the zeros. So replace 0 in, negative 2x to the 4th plus 2x squared. I hope you're saying factor, and you can take out I would take out negative 2x squared. When I do that, it leaves me with x squared minus 1. That being this x squared minus 1 still being factorable as a difference of 2 squares. So 3 zeros here. 3 zeros coming as x equals 0, x equals 1, and x equals negative 1. All right, so here I'm asking you to think about the problem backwards. Here I'm going to give you the zeros. I want to know what is the polynomial function with these zeros. And in this kind of relates back, if you go back to the last slide, well, 1 was a, right here, 1 was a 0. What was its factor? X minus 1. Well, if I take that information to the very next slide, 3 is a 0. What was its factor? This, x minus 3, was its factor. Well, negative 3 was a 0. What was its factor? I could say x minus negative 3, but it's way easier to just say x plus 3. And if I said negative 1/2 is a 0, what was its factor? X plus 1/2. All right. This essentially now, this is a polynomial function, but I'm more concerned with what are all the coefficients. The way we're going to find that is we're going to FOIL all this out. So these are these first two right here are extremely easy to FOIL because they're a difference of 2 squares. I hope you recognize that that's going to be x squared minus 9. And then all I have to do is FOIL it with x plus 1/2. So I do one quick FOIL, get x to the third plus 1/2 x squared minus 9x minus 9 over 2. That is my function. That has 3, negative 3, and negative 1/2 as its zeros. If you know the zeros, you know the factors, because they are only one step different. Okay, here's the same exact problem taken to a new level. Okay. So, again, if 3 is a 0, what's its factor? Well, if 3 is a 0, then x minus 3 was its factor. Now, 2 plus radical 11 is a 0. What's its factor? Well, it's a positive 2 plus radical 11, meaning x minus 2 plus radical 11 is its factor. And the same thing here. If 2 minus radical 11 is a 0, then x minus 2 minus radical 11 is a 0. Okay, this looks a little bit tricky, but there is a big shortcut that I can show you here, and it revolves around distributing these minus signs. So keep the x minus 3. We're actually not going to touch the x minus 3 for quite some time. So I'm going to rewrite this as x minus 2 minus radical 11. I'm going to rewrite this as x minus 2 plus radical 11. So what I want to think of this as is I'm going to focus on this section right here. How do I multiply these? And there's an easy way to do it. And the reason there's an easy way to do it is because both of them have an x plus 2, and both of them have a radical 11. The only thing that's different is a plus or minus sign. Essentially, if you think of this x plus 2 right here as kind of like your first term, and this radical 11 and negative radical 11 as your second term, it's really a difference of squares, which means all I really have to do is, again, keep the x minus 3 along for the ride for right now. I'm going to multiply x minus 2 times x minus 2, that is x minus 2 squared. And then right here, it's going to be radical 11 squared, which is just going to be minus 11. These two pieces, all right here, have all simplified down to this this second set of parentheses. Now it's just keep the x minus 3 along for the ride. If I FOIL this x minus 2 squared, that's x squared minus 4x plus 4 minus 11. So I could combine like terms. You might have been able to do that step in your head. Minus 4x minus 7. And then the last part to this would be to FOIL this one more time. I get x cubed minus 4x squared minus 7x minus 3x squared plus 12x plus 21. And combining a few like terms, my answer will be x to the third minus 7x squared plus 5x plus